Hello everyone. So we are from Group 5 for the compressor tutorial for question 5. And the group members is Nur Adriana, May Wilson, Muhammad Fitri Hakimi, Nashrin, Noria Natasha, and Anis Rosli. So for the schematic diagram of air compressor, firstly you can see that the air will flow into the suction and then the rotor will compress the air and discharge the compressed air in high pressure. So from this we can see that the mass energy in and then there is working, there is a heat out and also mass energy out. So for this energy balance equation, energy in is equal to energy out since the rate of change in energy of the system is equal to zero for the steady flow. And therefore, we calculated the working is equal to mq out plus with m times with h2 minus h1. So that's it for my part. And move on to the next slide.
Hello and hi everyone. I am Nashwin here. I'll be explaining regarding the function of air compressor. As we know that compressor there are many types and one of them is actually air compressor. So basically a function of compressor is to lowering the pressure on the suction side of the system, and the compressor will also increase the pressure in the discharge side of the system, as we can see in the picture at our right hand side. And compressor also are responsible to reduce the volume and induce the pressure in the compressed air. And the next last thing the compressor will be doing is compress and store air inside the air receiver, as what we can see in the picture in the right. Next, I would like to pass the slide to May Wilson.
Hi, my name is May Wilson. I will explain the application of the air compressor. Air compressor is a pneumatic device that converts power into potential energy stored in pressurized air. Air compressor can be used in our daily life. There are four applications, which is adding air to tires on bikes and on vehicles, cleaning crevices and tight spaces on equipment or other durable items with directed air pressure, painting with an airbrush for small precision projects or on a larger surface like bikes and the body of vehicles and recreational vehicles, and last but not least, blowing up balloons or inflatable products. Now I will pass to Cody.
Okay, I am Muhammad Fitri Hakimi, and now we proceed with the question 5 from the tutorial. So we look into the question. First, when we look to the question, we have to extract the information. Before that, we have to draw the schematic diagram so we can have a clear vision of the compressor. And we extract the information from the question. At the inlet, it is stated that they have a low velocity, so we assume that the velocity is 0 meter per second. And we have extract information at the outlet, and then the energy. So to make the calculation become more easier, we have to convert the unit, and then we proceed with the energy balance equation. As it is a steady state, so E in equal to E out, and then we arrange the equation so we can have this equation. We can have this equation of the mass flow rate. Okay, we have the all of information. We have W in, we have Q out, we have V2, we have V1, but we don't have H1 and H2. So we must find the H1 and H2. So to find it, we have to find, as the T1 is 298 Kelvin, so we find the specific enthalpy at 298 Kelvin. So does the H2. We do the same. We got the H1 and H2 from the table, from the properties table. And then we put all of information into this equation. So we continue to calculate it until we get the answer 0.678 0.674 kilogram per second. But please remember that don't forget to change the unit of this information, because 1 kilojoule equal to 1000 kilogram meter square per second square. That's all from me. Thank you.